Pulse oximeters consist of a peripheral probe and a small microprocessor unit. Traditionally, the peripheral probe contains a photodetector and two light-emitting diodes. The two light-emitting diodes emit light of different wavelengths. The light emitted by the diodes is absorbed by tissues, and the amount of absorption is determined by the photodetector. Using this information, the microprocessor determines the concentration of oxyhemoglobin and deoxyhemoglobin, respectively. It then calculates the percentage of oxyhemoglobin and displays the hemoglobin-oxygen saturation in arterial blood, a waveform corresponding to the pulsatile flow in arterial vessels and the heart rate. Pulse oximeters function on the principle that oxygenated and deoxygenated hemoglobin absorb red and infrared light differently. The light absorption of deoxyhemoglobin is greater at wavelengths of 600 to 800 nanometers, while the light absorption of oxyhemoglobin is greater at wavelengths of 800 to 1000 nanometers. One light-emitting diode emits light in the red spectrum at a wavelength of 660 nanometers, at which the light absorption of deoxyhemoglobin is greater than that of oxyhemoglobin. The other diode emits light in the infrared spectrum at a wavelength of 940 nanometers, at which oxyhemoglobin absorbs more light than deoxyhemoglobin. The microprocessor analyzes the light absorption of the tissues at each wavelength to determine the respective concentrations of oxyhemoglobin and deoxyhemoglobin. It then divides the concentration of oxyhemoglobin by the sum of the concentration of oxy and deoxyhemoglobin to determine the arterial blood oxygen saturation, SpO2. The probe is positioned so that the photodetector and light-emitting diodes face each other, with layers of tissue between them. The photodiodes turn on and off several hundred times per second to record the light absorption during pulsatile and non-pulsatile flow. During pulsatile flow, the light absorption of arterial blood, background tissues, and venous blood is detected. During non-pulsatile flow, only the light absorption of background tissues and venous blood is detected. The microprocessing unit compares the light absorption during pulsatile and non-pulsatile flow to isolate the light absorption of arterial blood and thus determine the arterial blood oxygen saturation.